Yeah, next question. So in this question we are told to maximize this function that we are given. Okay, maximize. So firstly I'm just letting it equal, let f of x equal to this. Okay, means basically this function. And now we have two constraints. Okay, but these are in the form of inequalities. One constraint in the form of inequality. Whenever we have such a constraint, no, so basically we take it, we need to solve it only using our Tucker method. We can't use our Lagrangian method to solve this kind of inequality. Well, that's just what I think. I'm not sure, but finally, that's just how I do it. Yeah. Okay, so now we get a constraint here. This is a constraint. Now, in order to start solving, we start with this. Okay, by Tucker conditions. Also, we can define a Lagrangian function. Also, define a Lagrangian function that we would get as a function of x1, x2, and lambda 1, which is f of x1, x2 minus lambda 1, h1, which is this, I guess, 10x1 plus 4x2 minus 2x1 square minus x2 square minus lambda 1 into our constraint 2x1 plus x2 minus 5. Now by Tucker condition, they tell us that del L by del x1 should be equal to 0, del L by del x2 should be equal to 0, x1 and x2 should be greater than equal to 0, and since we want to maximize, our lambda should be greater than equal to 0, and lastly, our lambda 1 into h1 must be equal to 0. Okay, this is the main thing over here. This is what we are going to be using the most. But firstly, we need to calculate this and this. So del L by del x1 is basically, we get 10, then we get minus 4x1 minus 2 lambda 1 equal to 0, and then our del L by del x2 is equal to by x2, no? So 4 minus 2x2, 4 minus 2x2 minus lambda 1 equal to 0. Okay, so now on solving these two, but we won't solve it immediately. Okay, these are equations. Okay, and lambda 1 into h1 is also another equation, lambda 1 h1, which is basically this one, 2x1 plus x2 minus 5 into lambda 1 equal to 0. So now let's take case 1. Okay, like entire game revolves around this. In case 1, we assume lambda 1 equal to 0 because we have already taken, no, lambda 1 can be greater than equal to 0. So yeah, lambda 1 equal to 0. So now we assume lambda 1 is equal to 0 from these equations, okay, 1 and 2. If we put lambda 1 as 0, we'll get x1 ka value as 5 by 2 and x2 ka value as 2. Okay, x1 we'll get as 5 by 2 and x2 as 2. Also, before we proceed, I forgot one thing. H1 should be less than equal to 0. Okay, H1 is this, no, 2x1 plus x2 minus 5 less than equal to 0. That is also a very important condition. Let's call it condition 3. Okay, yeah. So now, in order to check whether this is a valid solution or not, we substitute it over here in equation 3. So by putting it in equation 3, we would get 5 plus 2 minus 5 should be less than equal to 0. As you can see, we get 2 is less than equal to 0, but however, this is not possible. Therefore, case 1 is invalid. Therefore, lambda 1 is not equal to 0. We know that for sure. Okay, so now we move on to case 2. Case 2 says that h1 equal to 0. Therefore, we get 2x1 plus x2 minus 5 should be equal to 0. And we also have from our equations 1 and 2, if we rearrange, we'll get 10 minus 2 lambda 1 upon 4 as x1. So we'll get x1 as 10 minus 2 lambda 1 upon 4, which can be simplified down to 5, 5. So we get 5 minus lambda 1 upon 2. That's a x1. And for x2, we'll get 4 minus lambda 1 upon 2. x2 is equal to 4 minus lambda 1 upon 2. Now, we can substitute x1 and x2 in this equation. Let us call it a, okay? Okay, so now here, we need to just substitute this in this equation here, the values of x1 and x2 that we obtain, so as to get the values of lambda, which will help us get x1 in return. So on substituting, we get 2 into 5 minus lambda 1 upon 2, 2 cancel, plus 4 minus lambda 1 upon 2 minus 5 is equal to 0. Multiplying by 2, we get minus 2 lambda 1 plus 4 minus lambda 1 minus 5 is equal to 0. And this will become 10. So this 10 gets cancelled, this 10 gets cancelled. Minus 3 lambda 1 is equal to minus 4. Therefore, lambda 1 is equal to 4 by 3. Now, we can substitute this over here in these two equations to get values for x1 and x2. I'll just calculate that. 5 minus 4 by 3 divided by 2, we get x1 as 11 by 6, and for x2 we get 4 minus 4 by 3 divided by 2 as 4 by 3. Therefore, our stationary point we found is 11 by 6, comma 4 by 3. Now, as lambda ka value is greater than equal to 0, we can state that this is the point of maxima. Now, in order to find the maximum value of the function, all we need to do is just substitute the value of the point 11 by 6, comma 4 by 3 in it. So now our function is this now. So 10 into 11 by 6 plus 4 into 4 by 3 minus 2 into 11 square by 6 square minus 4 square by 3 square. We get 91 by 6, which is 15.166. It's 91 by 6, 15.1667. And this is the maximum value of our function. Nice.